There's a particular kind of silence in the workshop that tells you something isn't lining up. You've opened the key carefully. You've exposed the board without damaging the coil. You've connected your tool exactly the way the diagram suggests, and you're confident you're about to pull the data you need. And then the screen flashes back a message that changes everything. Function not supported. Use another programmer first. In that moment, it's not just about the tool. It's about understanding the platform, the firmware stage, and what's actually happening behind the scenes inside that tiny MQB key. Welcome back to Baabji Motors. I'm Hussein, and today we're diving into a very specific but increasingly common situation involving VAG MQB49 5C and 5D keys, Xhorse tools, and why your Key Tool MIDI might not be doing what you expect it to do. This discussion is strictly educational. We're breaking down tool behavior, supported functions, and technical workflows so technicians and learners can better understand the system architecture. Always follow manufacturer guidelines, local laws, and proper workshop safety procedures when working with Immobilizer systems. Here's the real-world scenario. You disassemble an original VAG MQB49 5C key. Your goal is simple. Read the key data so you can prepare and add a spare key. You go into the Xhorse Key Tool MIDI menu. You see the option for MQB key operations, and you attempt to read the data directly from the keyboard. But instead of proceeding, the tool informs you that the function is not supported and suggests that the key must first be read using a VVDI programmer. This is where clarity matters. The Key Tool MIDI, as of current functional capability, does not support direct reading of original MQB49 5C or 5D key data by disassembling the key and accessing the board. Even though the menu option may appear, the backend support for fully reading those original encrypted datasets is not enabled in stable firmware. When the message references a VVDI programmer, in this context, it's pointing toward the Xhorse Multi Prog platform. Multi Prog is a newer generation hardware designed to handle more advanced MCU, EEPROM, and encrypted key reading tasks. It's built to bridge some of the gaps left by older standalone key tools. However, and this is important, the MQB49 5C and 5D key reading function on multi-prog has been in a testing phase rather than a fully stable public release in certain firmware versions. That means not every unit or firmware build will expose the feature in the standard menu. Xhorse has historically rolled out advanced functions through test channels before pushing them to official releases. If you want to access experimental features, there's typically a test access path inside the tool interface. For example, entering the Help section and selecting a designated test channel, often labeled with a specific internal code, can enable features under evaluation. These test modes are not guaranteed to be fully stable. They are designed for experienced users who understand the risks of beta-level operations. Now let's talk about the hardware side, because with MQB keys, software alone is never the whole story. To read MQB49 5C or 5D key data using multi-prog, you often need to modify the MCU adapter wiring. Specifically, two ground wires on the adapter, commonly referred to as the short ground and long ground black wires, must be adjusted according to the updated wiring diagram provided by the manufacturer. This modification ensures correct grounding reference and signal stability when interfacing with the key's microcontroller. MQB keys operate on tightly controlled communication lines, and signal integrity is critical. If your ground reference floats or your clock line isn't clean, the MCU simply won't respond correctly. That's why wiring accuracy matters just as much as tool capability. Xhorse provides wiring diagrams showing the correct connection points between the multi-prog adapter and the MQB key board pads. These diagrams typically illustrate VCC, GND, CLK, DATA, and sometimes RST lines depending on the MCU variant inside the key. MQB49 5C and 5D keys can contain different microcontroller revisions, and that's another reason why compatibility can feel inconsistent. Here's another practical tip that often makes the difference between failure and success. If the tool fails to read key data even after correct wiring, inserting a 100 ohm resistor in series with a clock line can stabilize communication. This small resistor acts as a signal dampener, reducing noise and ringing on the CLK line. In high-sensitivity MCU communication, especially when working with exposed boards outside their original housing, signal reflections can interrupt data exchange. A simple series resistor can smooth the waveform enough for reliable reading. This isn't guesswork. It's basic electronics behavior. Long jumper wires, unstable grounds, and bench setups without proper shielding can all introduce interference. When you're working with encrypted Immobilizer MCUs, even minor instability can result in read failures. Another important detail is that original MQB keys are protected with encryption tied to the vehicle's Immobilizer system. Reading raw data from a key is not the same as generating a dealer key. The data inside includes synchronized information related to the vehicle's Immobilizer cluster, or BCM. That's why tool manufacturers are cautious with full support. It requires correct decryption handling and firmware validation. So to answer the original question clearly, the Key Tool MIDI alone does not currently support direct reading of original MQB49 5C and 5D key data through disassembly. The system expects that reading to be done with multi-prog hardware. Even then, functionality may require test channel activation and proper adapter modification. If reading fails, stabilizing the clock line with a 100 ohm resistor is a known troubleshooting step. At Baabji Motors, I always encourage technicians to look beyond just menu options. Tool capability depends on firmware stage, hardware revision, wiring integrity, and sometimes even subtle electrical conditions. Immobilizer work is precision work. There's no shortcut for understanding the fundamentals. Earlier, I asked what's actually happened behind the scenes when that function not supported message appears. The answer is simple. The software interface may display a pathway, but the firmware backend has enabled stable support for that MCU type in that specific tool. It's not user error. It's stage development. Personally, I believe that as multi-prog firmware matures, full stable support for MQB49 5C and 5D keys will become standard without requiring test channels. But until then, careful wiring, firmware awareness, and realistic expectations are key. If you're working on these platforms regularly, here's one extra practical insight. Always power your setup with a stable bench supply rather than relying solely on USB power when doing sensitive MCU reads. Clean power can significantly improve success rates, especially when working with exposed keyboards. Now I'd like to hear from you. Have you successfully read MQB49 keys with multi-prog in test mode, or are you still waiting for a stable public release? Drop your experience in the comments. Let's aim for 1,000 likes and 100 solid technical comments on this one. Only a small percentage of viewers are actually subscribed, and subscribing genuinely helps Baabji Motors grow, reach the #1 spot in this niche, and continue producing deep technical breakdowns like this. Detailed analysis takes time, testing, failed attempts, wiring trials, and real workshop validation. Your likes, shares, and subscriptions directly support that effort. If you decide to pick up any of the tools discussed, check the description. If affiliate links are available, they help support the channel at no extra cost to you, and that transparency matters. Thanks for spending your time here. Keep sharpening your diagnostic thinking. Keep questioning tool behavior instead of blindly trusting it. And most importantly, keep pushing your technical limits. I'll see you in the next one.